All right, so today we're diving into particle physics. It sounds kind of complicated, right? But stick with me. You sent over some articles and notes about it, and honestly, I'm curious too. So let's break it down together and unlock some secrets of the universe.
It's like looking at the tiniest pieces of everything, and one of the most important is the Higgs boson. Ever heard of it?
Oh yeah, the Higgs boson. It's famous for its nickname, the God particle. But that always seemed kind of misleading to me.
Yeah, it can definitely cause some confusion. It's not about religion or anything like that. The Higgs boson is really about why stuff has mass.
Okay, so why does stuff have mass? What does this Higgs thing have to do with it?
Okay, imagine a room full of people, and then a celebrity walks in. Everyone swarms them, right?
Yeah.
Suddenly, it's hard for the celebrity to move.
So the celebrity is like a particle, and the crowd
Mm-hmm.
is at the Higgs field.
Exactly.
Hmm.
The more a particle interacts with the Higgs field, the more crowded it gets, and the more mass it seems to have.
So the Higgs boson is kind of like the celebrity particle. It's the one that gives other particles their weight. And scientists actually found this particle.
They did. Back in 2012, they confirmed it. They used something called the Large Hadron Collider.
Hold on, the Large Hadron Collider. What is that exactly?
Imagine a giant microscope, but instead of looking at tiny things, it smashes them together. At super high speeds, close to the speed of light, it's located underground in Switzerland, and it's the biggest, most powerful particle collider we have.
Wow, massive tunnels, tons of energy, all to look at these tiny, tiny particles.
It is a pretty big deal. Finding the Higgs boson was a huge win. It actually confirmed a big part of what's called the Standard Model. It's basically our best understanding of how the universe works, at its most fundamental level, I mean.
So the Standard Model is like the rule book for the whole universe.
I'd say it's more like a blueprint, explaining how all the fundamental pieces fit together.
We've got this amazing machine, the Large Hadron Collider, smashing particles, helping us understand the universe. But I feel like this is just the tip of the iceberg, right? There's so many particles out there.
Right, and there's another player entering the game soon. China's building not one, but two massive colliders, the CEPC and the CPC, both pushing the boundaries of particle physics even further.
Whoa, two of them. What's the big attraction with colliders? Why are they so important?
Well, they can help us unlock some massive mysteries, like dark matter, for example. It makes up most of the universe, but we can't even see it.
So how do we even know it's there? If it's invisible, I mean.
We know it's there because of its gravity. It affects things we can see, like galaxies. They spin much faster than they should based on the matter we can see.
So dark matter is like the universe's hidden puppet master.
It's like a cosmic ghost, holding everything together behind the scenes. And colliders like the LHC and the new ones in China, they could be the key to finally figuring out what dark matter really is.
Okay, dark matter, invisible particles. This is already blowing my mind. But I have a feeling there's even more to this story, right?
Yeah, I bet there is. For example, colliders are also helping us study quarks. These are the even tinier particles that make up protons and neutrons, the stuff that atoms are made of.
So we're going even deeper to the building blocks of matter itself.
Exactly. It's fundamental stuff. And as we dig deeper into these quarks and other particles, we might even start answering some of the biggest questions about the very nature of reality.
Wow, okay. Higgs boson, giant colliders, dark matter, quarks. It's a lot to take in. But it's seriously fascinating stuff. It makes you realize how much we don't know about the universe yet.
Exactly. And that's what makes it so exciting. Every new discovery opens up even more questions to explore, and sometimes those explorations lead to unexpected places, with real-world benefits that we never could have predicted. It's true, it can seem kind of abstract, this particle physics stuff, but it actually has a big impact on our lives.
Really? Like how does smashing particles in a giant tunnel help me in my daily life?
Well, for example, have you heard of proton therapy? It's this amazing cancer treatment. It uses proton beams to target tumors super precisely, and it wouldn't be possible without research from particle physics.
Wow, I had no idea.
Yeah.
So it's not just about these abstract theories then. It's about understanding the universe so we can solve real problems.
Exactly. And it's not just proton therapy. Particle physics has helped develop faster computing. Even the World Wide Web was created at CERN. That's where the LHC is.
Whoa, so no particle physics, no internet?
It's safe to say it played a huge role. Particle physics has shaped the modern world, even if we don't always see the connection.
Okay, so we've got the Higgs boson, giant colliders, dark matter, quarks. It's all super fascinating, but also these colliders cost billions of dollars. How can we justify that kind of expense?
It's a fair question, and it's one that scientists debate all the time. But history shows us that investing in basic research pays off. even if we don't see the benefits right away.
So it's kind of like planting a seed. It might take years to grow into something big.
Exactly, a perfect analogy. Think about electricity. Back when it was first discovered, no one could have imagined how it would change the world.
And now we literally can't live without it.
Exactly, and who knows, maybe in 100 years we'll be saying the same thing about dark matter.
Okay, you've convinced me. Basic research is definitely worth it. But let's talk about the discoveries themselves for a minute. What have we actually learned from these colliders?
Aside from the Higgs boson, one of the biggest areas is understanding protons and neutrons, the particles that make up the nucleus of an atom.
Okay, remind me, what are they made of again? It's,
Quarks, they're these even tinier particles. And there are 6 different types, each with its own personality.
6 types. Seems like a lot to keep track of.
Haha, it is. And they have these kind of funny names like up, down, charm, strange, top, and bottom.
Up, down, charm. Sounds like a Dr. Seuss book. But seriously, what have we learned about them?
Well, by smashing protons and neutrons together, we can study how these quarks interact and how they give matter its properties.
So it's like zooming in on the building blocks of, well, everything.
Exactly. And what we found is those interactions between quarks are super complex. They're governed by one of the 4 fundamental forces of nature, the strong nuclear force.
Hold on, 4 fundamental forces.
Yep. There's the strong force holding the nucleus together. Then there's the weak force, which causes radioactive decay. And of course, electromagnetism and gravity.
But particle physics is all about understanding these forces and how they shape the universe.
It's a big part of it, yeah. And the more we learn, the more we realize how connected everything is.
My brain is definitely feeling a little overloaded right now. But in a good way. It's amazing to think about the scale of all this. These colliders are miles long, costing billions. It's a huge effort.
It is, but it's a testament to human curiosity. These colliders are like modern-day cathedrals, monuments to our pursuit of knowledge.
I love that analogy. We're building these giant temples of science to explore the universe.
Speaking of global efforts, I read that China's getting really serious about particle physics. Absolutely. They're investing heavily in research and building some super ambitious colliders of their own.
It's like a new space race, but for particles.
Haha, yeah. And it's good for everyone. The more countries involved, the faster we'll learn.
It feels like we're on the edge of some major discoveries. But with all this excitement, what are some of the biggest challenges?
Well, just the complexity of these experiments is a challenge. Building and running these massive colliders is a huge feat. It requires a ton of international collaboration.
It's like coordinating a giant orchestra with scientists from all over.
Exactly. And then there's the data. These experiments produce mountains of it, petabytes of data that need to be processed and analyzed.
So it's not just about the machines, it's about making sense of the data too.
Exactly. And then, of course, there are the theoretical challenges. We're still trying to find a single theory that can explain all the fundamental forces in particles.
Ah, the elusive theory of everything.
The holy grail of physics. It's a goal that's driven physicists for generations.
It's wild to think about how far we've come. From thinking the Earth was the center of everything to knowing we're just a tiny part of this vast, expanding universe. A universe full of dark matter, dark energy, and who knows what else.
It's humbling and also kind of exciting, right?
Absolutely. It makes you wonder, with all these discoveries and scientific endeavors, how does it all connect back to our everyday lives?
That's a great question. And the answer is, particle physics has a much bigger impact than you might think.
For example, give me some concrete examples.
Well, think about all the technology we rely on. Smartphones, computers, medical imaging. All of that is built on principles discovered by particle physics.
So no particle physics, no smartphones, no MRI scans.
You got it. And then there are all the spin-off technologies, things like superconducting magnets used in MRI machines and particle accelerators used for cancer treatment.
Wow, I had no idea those things were connected to particle physics.
They are. It's amazing how something so abstract can have such a direct impact on our health and well-being.
It's incredible. But it's not just about technology in medicine, is it?
Nope. Particle physics also affects how we understand the world. It helps us appreciate the interconnectedness of everything, from the tiniest particle to the largest galaxy.
It's like gaining a whole new perspective on the universe.
Exactly, and that can be a powerful thing.
Well said. You give me a whole new appreciation for the importance of particle physics. It's not just some abstract field, it's about understanding reality itself.
It's about pushing the boundaries of knowledge and exploring the great unknown. It's a journey that never ends.
I totally agree. It's been an amazing conversation. Thanks for taking us on this deep dive into particle physics.
You're welcome. It's been a pleasure.
All right, welcome back for the final part of our particle physics deep dive. We've covered a lot of ground, haven't we? Higgs boson, those quarks. We even talked about giant underground colliders and dark matter.
Yeah, it's been quite a journey through the universe's building blocks.
I feel like I'm starting to get a grasp on this stuff, but there's always more to learn, right?
Mm.
What else are physicists working on?
One of the biggest mysteries is this stuff called dark matter. It's invisible, but it makes up a huge chunk of the universe's mass.
Wait, invisible. We can't see it at all.
Not directly, no. We know it's there because of its gravity, though. It pulls on things we can see, like galaxies. They're spinning way faster than they should be, based on the matter we observe.
So it's like this hidden force affecting everything.
Yeah, like a cosmic ghost. And then there's dark energy, which is even weirder. It's what's causing the universe to expand and accelerate, in fact.
Hold on, the universe is expanding. I thought it was just, there.
It is expanding, and it's getting faster all the time, like something's pushing everything apart.
Whoa, okay, so dark energy is like the universe's gas pedal. But what is it exactly?
That's the big question. We really don't know. It's one of the biggest unsolved mysteries in physics.
So we've got dark matter, the cosmic glue, and dark energy, the accelerator.
Yeah.
What are scientists doing to try and figure them out?
Well, with those powerful colliders, they're trying to actually create dark matter. Imagine actually seeing one of these invisible particles.
That would be incredible, a major breakthrough.
It would be huge. But scientists are also using other methods. They're building super sensitive detectors, trying to catch dark matter particles as they pass through the Earth.
Like setting a trap for a ghost.
Exactly. And of course, lots of theorists are working on the problem too, trying to develop new models and theories to explain it all.
It's amazing to think how much our understanding has changed. 100 years ago, we thought Earth was the center of everything. Now we're talking about dark matter and a universe that's constantly expanding.
It is pretty humbling, and it shows us how much more there is to discover.
This deep dive has been truly eye-opening. There's a whole hidden universe out there just waiting to be explored.
Exactly. And with every new discovery, we gain a better understanding of our place in the cosmos.
It's been a fascinating journey. Thanks for joining us on this deep dive into particle physics.
It's been my pleasure.
Keep those minds curious, folks, and we'll catch you on our next deep dive.